Mechanics is coming up soon, and none of us want to be cooked for mechanics, so this is how you do a question 3 off the mechanics paper. It states, a particle P of mass 0.5 kilograms moves with a constant velocity 2I minus 2.4j on a smooth horizontal plane under the action of a constant horizontal force, F newtons. So if we sketch this out real quick, we're going to have a particle of mass 0.5. I'm just going to put a g there just in case that matters. And it's moving with a constant acceleration, so it's going to be moving double arrow for acceleration 2I minus 2.4j meters per second squared on a smooth horizontal plane with a constant force F, and F is just going to go there. We'll just say F there. So part A is find F in terms of A and G. Now, as we know, this is a constant acceleration question with a force, so we're going to use F equals ma. So we're going to have F as F because they just match up. So F equals, it's got a mass of 0.5 and a constant acceleration of 2 minus 2.4. And then literally all you need to do is times it out. So F equals 0.5 times 2 is 1. 0.5 times minus 2.4 is minus 1.2. And I want it in terms of I and j. So that's just I minus 1.2j. That's part A. And then part B. Find the velocity of p at time equals 2 seconds. Now this is obviously going to be a suvat, because again, constant acceleration, you can always just assume this is going to be a suvat question. We have at time t equals 0, p is moving with velocity minus 7I plus 7.8j. So that's going to be our u. And then we know a is 2I minus 2.4j. And we're looking for when t equals 2. Now, what do we have here? The two suvats I always like to use are s equals ut plus a half at squared, or v equals u plus at, because that kind of covers all your bases. You have u, t, and a there. You have v, u, a, t there. That's covering everything. So no matter what I get, I can always form some sort of simultaneous equation that, even if it's a little bit like dodgy, it works. So I can obviously see I've got u, a, and t, and I'm looking for v. U, A, T, V. So V equals U, which is minus 7, 7.8, plus AT, which is going to be 2 lots of 2 minus 2.4. Always work with columns because it's just easier. So V equals minus 7, 7.8, plus 4, 4.8, 4 minus 4.8. Minus 7 plus 4 is 3. Minus 3. Minus 7 plus 4 is minus 3. 7.8 minus 4.8 is 3. Plus 3j. Cool. And that is part A and B done. Part C, find the direction of motion at t equals 2 seconds, giving your answer as bearing. Now, if you remember from bearings at GCSE, bearings must be a... So I'm going to have this. Let's say we have this. Bearings start from north and they move clockwise. So if we look at what we have minus 3i plus 3j, and that's the bearing we want. We want minus 3i plus 3j, and this is for part C. So that's going to be 3 this way, and then 3 up. And that's going to create this here. I'm going to say this is theta. I'm just going to draw a vertical line and say this is north. So the bearing, which is going to be a clockwise bearing this way, it's going to be all of this plus this theta. Now, ignoring the theta for now, we know that this I is horizontal. So this vertical horizontal, it's obviously going to form to be 90 degrees. So we can say 360 minus 90 is this. We'll call that alpha. So alpha equals 360 minus 90, 270. Now I know this is going to be 3, and this is 3. So I have an opposite and an adjacent. So I can say that tan theta equals opposite over adjacent, 3 over 3. So theta equals tan to the minus 1 of 1. So theta equals 45 degrees. It's an exact value. And then for the bearing, from here all the way around to my line, this line here, I need to just add theta to alpha. So theta plus alpha is my bearing, which is 315. Just going to check that. Don't trust my mental maths. Yeah, 315. So it's traveling on the bearing, 315 degrees. So I'm just going to put a box around that to signify that, I can just do this. Bearing, 315 degrees. Cool. And then part D, find OI, OA in terms of I and J, given that at time t equals 5 seconds, P passes through the point A. And it's just going to be, this one's going to be even easier. It's literally just another suvat. So we'll say this is part D. What am I doing? Part D. I want that T is 5. So I'm just going to have another suvat. And if you remember, so this one's asking for a distance. So the only ones that I like to use are S equals UT plus a half AT squared, or V equals U plus AT. This one's given me distance, and if I look, I already have U, A, and T, so I'll just use that. So I have, this is X, minus 7I plus 7.8J. I'm looking for 5, and then my A is 2I minus 2.4J. Minus 2.4J. And then if I just substitute everything back into this one here, I'm going to have that X equals U T plus a half AT squared. I'm just going to write it like this. You'll see why in a minute. Okay, so instead of doing this in my head, I'm just going to slam this into my calculator to make sure I do not get it wrong. Say, to finish the question is that OA equals minus 10I plus 9J. Done. And that is how you are not cooked for vectors. Thank you.